Hello everyone, this is Sandeep and you are watching Samyan's Academy, and in this session we are going to discuss about sound from class 8th. Let us start. Okay, what is sound? So sound plays an important part in our daily lives. It helps us to communicate with each other. We hear a wide variety of sounds in our surroundings. Sound is produced by a vibrating body. Vibration is a to and fro, back and forth motion of an object. Then how we are getting the sound? When object vibrates, the sound is produced. When object vibrates, what will happen? The object will get to and fro motion. Okay, then only the sound is produced. Okay, in that way we can hear the sound. Now you see here we have some instruments, right? If you strike a school bell, it vibrates and produces sound. If you plug a stretched rubber band, and in this way also we can produce the sound. If you beat a drum, its stretched membrane vibrates and produces the sound. If you blow a bugle, the air column vibrates and produces sound. Okay, from all these examples we observe that when object vibrates, it creates some sound. Okay, here we have some musical instruments. Then how do you get the sound from this bell? When you strike the bell with any hammer, right, anything, then it will vibrate and it produce the sound. Here we have some drums here, right? In these drums we have a stretched membrane. When you beat the stretched membrane, the stretched membrane will get vibrate and it will produce the sound. Now here we have some bugle. When you blow this, the air column enters into it. The air enters into that column, then that air column get vibrate and also it produce sound. Okay, from all these examples we know that when object vibrates, it produces the sound. Okay, now what is vibration? Vibration means to and fro motion of an object, we called as vibration. Okay, and now here we have some musical instruments. In veena, vibrating part producing sound is a stretched string. In sitar, here also vibrating part of producing sound is stretched string. And violin, stretched string. Tabla, stretched membrane. Mridangam, stretched membrane. Drum, stretched membrane. Shehnai, air column. Flute, air column. Mouth organ, air column. And these are the vibrating part of the corresponding musical instruments, right? Now move on to this. Some musical instruments produce sound when they are beaten or struck. Example: bell, gatan, manjira, jal tarang. Okay, all these examples for the vibrating bodies. When you beat this, it will vibrate and it creates some sound. Okay, and sound produced by the humans. In human, sound is produced by the voice box or called larynx, and it is the upper part of the windpipe. Two vocal cords are stretched across the voice box, leaving a narrow slit. When the lungs force air through the slit, it vibrates and produces sound. Now here we can observe some image also. Okay, and this is our larynx box. This is a voice box. We can feel here when you touch here. This is the one box is that larynx. This is we called as a larynx. Okay, so it is the upper part of the windpipe. So where is the location of the windpipe? It is the upper part of the windpipe, and this is the larynx. Larynx where we can observe it is the upper part of the windpipe. So how we can see this structure? Here larynx has some narrow slit. When you blow the air to it, it will vibrate and produce the sound. When the lungs force air through the slit, it vibrates and produce sound. Sorry. So here we have some slit. When you blow the air, what will happen? It will get vibrate and produce the sound. Now you see, sound requires a medium to propagate. Sound travels through solids, liquids and gases. Sound does not travel in vacuum. Okay. Sound travels through the solid thread of a telephone. A whale listens to the reflected sound in the water to locate its prey. We are able to listen to sounds because sound travels in air. Okay. So to travel the sound, it requires some medium, right? So it can travel through the solid medium, or it can travel through the liquid medium, or it can travel through the air medium, but it cannot travel through the vacuum. Okay, sound cannot travel through the vacuum. When you speak on the moon surface, are you able to hear the sound? No, we cannot hear the sound on the moon surface. Why? Because there is no atmosphere on the moon. So that if there is no medium, the sound cannot travel from one place to another medium, another place. Okay, sound cannot travel through another place. So to travel the sound, it requires medium. Okay, sound travels through the solid thread of can telephone. Here we have these two persons are hearing some, they made from can telephone. One person is speaking, other person can listen her sound through this wire. Okay, and will produce the sound. Okay, when it produces some ultrasonic sounds, it will go to the prey and it will come back to this whale. Because of the reflection of the sound, it will catch the prey. Means what is happening here? A whale listens to the reflected sound in water to locate its prey. Right. Now you see, we are able to listen to sound because sound travels in the air. So I am speaking, now you are listening. Then how that sound is coming to your ear? Through air particles or air medium. When air vibrates, the sound propagate through the air and it reaches to your ear. Right. Now here we have some experiment. When you perform this activity under the vacuum, we cannot hear the sound. Right. How we hear sound? Through our ears. Now how we are able to hear the sound? Here the structure of our ear. So let us see now. Sound enters the ear through the ear canal. It makes the eardrum to vibrate. The eardrum sends the vibrations to the inner ear. From there the signals go to the brain and then we hear the sound. Okay, and here this is we called as ear canal. Then sound passes through this ear canal and it reaches to the eardrum. Okay, here we can see this eardrum. Okay, so when sound passes through it, it will get vibrate, right? And the eardrum sends the vibrations to the inner ear and it again it passes to the inner ear. This is a part of the inner ear and the sound reaches to this inner ear. Then what will happen? The signals go to the brain. Okay, these sound signals converted into electric signal and it will go to the brain through some sensory nerves, right? Then we hear the sound. Like in this way we can hear the sound. Now here we have some words: amplitude, time period and frequency of vibration. So vibration means you take one pendulum, right? So here we have one pendulum. Just you take this pendulum up to the point A. From here you leave it. Then what will happen? It will get to and fro motion like this: A to B, B to A to B, B to A through mean position O. It will get vibrate like that. So like that vibrations we called as oscillator motion. So vibration is a what? Vibration is a to and fro motion of an object. It is also called as oscillatory motion, right? Motion of a simple pendulum, when you observe here, then what is the amplitude? Amplitude means maximum displacement of this pendulum from the mean position is called as amplitude. Okay, so you see here we have a pendulum. When you move this pendulum up to here, it will get displaced from O to A. The maximum distance or the maximum displacement of the pendulum from the mean position to A is called as amplitude. Or we can move up to here, or also we can move up to somewhat height, right? So you have to define the amplitude. Means the maximum distance between the mean position to extreme position we called as amplitude, right? How will you define the amplitude? The maximum displacement of an oscillating body from its central position is called as amplitude, right? The O to A distance or the O to B distance we called as amplitude. The motion of the pendulum from one extreme position to other extreme position and back is called as oscillation. Then how do you calculate one oscillation? Means suppose the pendulum is moving from the O. Let us assume that it is moving from the O. Then it is coming to A and it is going to B and again it is come back to the O. So that is we called as one oscillation. In another way also we can assume that oscillation means suppose our pendulum starts from the position A. Again it moves to the B, again it is come back to the A. Means the pendulum starts from the position A and again it come back to the position A. That is we called as one oscillation, right? One oscillation means it starts from the A and it come back to the A. So that is we called as one oscillation. So when you starts from here, it will move up to B, again it will come back to the A. That is we called as one oscillation. The motion of the pendulum from one extreme position to other extreme position and back is called as oscillation. Here we have A to B and back to A, and it is start from the A and reaches to the B, again it comes back to the A. So this is we called as one oscillation, right? Now what is time period? So time taken to complete one oscillation we called as time period, right? So from A to B, again B to A, so it will take how much time? Let us assume it is taking 2 seconds. Okay, one pendulum is assumed, you assume this pendulum to move the from A to B, it has taken 1 second. Again for going back also it is taking 1 second, means total time is how much here? 2 seconds. To complete one oscillation it is taking how much time? 2 seconds. And what is the time period for this pendulum? That is 2 seconds. Is it clear? Right. So to complete one oscillation is called as time period. Suppose your fan is there. Let us assume for 100 rotations it will take 10 seconds. For one oscillation it will take how much time? Can you assume? 10 seconds. In 10 seconds it rotates 100 oscillations and 100 rotations. Okay, time taken to one rotation you have to calculate. Then how will you calculate? Like in this way you can calculate. Let us assume time period means time taken to complete one rotation or time taken to complete one oscillation we called as time period. So we assume that for 100 rotations, 100 rotation it has taken 10 seconds. Okay, for one rotation it will take how much time? How much time? 1 into 10 by 100, that is 10 by 100 is how much? 0.1 second. Is it clear? 0.1 second. It will take 0.1 second. Let us assume our fan is rotating 100 rotations in 10 seconds. You have to calculate for time period. Time period means time taken to complete one rotation. Okay, to complete one rotation it will take how much time? It will take 0.1 second. Is it clear? To complete one rotation it will take how much time? 0.1 second. The 0.1 second is the time period of that fan. Is it clear? Then means time taken to complete one oscillation we called as time period. Okay, now you see the time taken for oscillation is called as time period. Then what is frequency? The number of oscillations per second is called frequency. Okay, just now we discussed example. 100 rotations 10 seconds means 10 rotations 1 second. Within the 1 second it will complete how many rotations? 10 rotation. Okay, means the frequency of this fan is how much? 10 rotations per second. Rotations per second we called as frequency. Okay, number of oscillations per second we called as frequency. In 1 second of time it is rotating how many times? That is we called as frequency. Time period means time taken to complete one oscillation. Time taken to complete one oscillation is called as time period, right? Then what is the frequency? Number of rotations in 1 second. Number of rotations per second or number of oscillations per second. In 1 second of time the object rotates how many times? That is we called as frequency. Let us assume this fan is rotating. Let us assume this fan is rotating 10 times or 10 rotations in 1 second. Means what is the frequency of this fan? 10 rotations per second, or we call as 10 hertz. Okay, other units of the frequency is hertz. 10 hertz or 10 rotations per second. Suppose in our speedometer and when you drive the vehicles, we can observe the one odometer and speedometer is there, and another meter also there, that is rotations per minute. It will give the frequency of your vehicle wheel, right? Suppose if it is showing 4 into 1000 means 4000 rpm. 4000 rpm means the vehicle the tire of the vehicle rotates 4000 times in 1 minute. That gives the frequency. Number of rotations in 1 second time will give the frequency. Is it clear? The number of oscillations per second is called as frequency. The unit of frequency is hertz, or rotations per minute, or rotations per second. Now you see loudness and pitch of the sound. What is loudness? Loudness of sound depends upon the amplitude of the vibration. If the amplitude is less, the sound is feeble. If the amplitude is more, the sound is loud. Okay, for example, if you louder minds, if somebody is having louder voice, means he can speak loudly, means we can hear feeble sound or we can hear loud sound. We can hear loud sound means suppose for example in our surroundings the bomb is exploded. At that time what will happen? We can hear the bigger sound, right? Because of that sound, that our windows of our building also get vibrate. So that much it is having the vibration, means that is having the amplitude, means if amplitude is more, it is having the louder sound, it will produce the louder sound. If amplitude is small, it will produce the feeble sound. Feeble sound means we can hear very low voice, low sound, we can hear low sound. The loudness of sound depends on the amplitude of the vibration, right? If amplitude is less, the sound is feeble. So feeble means we can hear very lesser sound, right? If the amplitude is more, the sound is louder. Louder means already you know that the sound is bigger. The unit of loudness we can call this a decibel. Then how do you measure this unit of sound? In decibel. Decibel means small d capital B. You have to indicate the with letter small d and capital B. Now the pitch of sound depends upon the frequency of the vibration. If the frequency is less, the sound has low pitch. Sound of a drum, sound of an adult. Okay. Pitch means frequency of vibration. Frequency means number of oscillations per second. If sound is produced more oscillations, more vibrations in 1 second, means it has high pitch. Okay, if that sound is producing very less oscillations in the 1 second, means this the sound is having the less pitch. For example, for having less pitch sound is sound of a drum, sound of an adult. The pitch of a sound depends on frequency. Frequency means number of oscillations per second, we called as frequency. If the frequency is more, the sound has a high pitch. Sound of whistle, sound of a baby. Okay, the sound of baby produce the more pitch, it is having the more pitch. Okay, and the sound of the girl or sound of the woman are also having the high pitch. The sound of an adult is having low pitch. Okay, low pitch, high pitch. And what is the difference between the loudness and the pitch? In the case of loudness, you have to consider amplitude. If sound is having more vibration means already you know that sound how it will move, sound particles move through the air, right? Now here we can see here some waves are there, right? Means the height of the wave is more, means it has high amplitude, the sound is louder. The height of the wave is more, here we can observe some waves, right? If height of the wave is more, it has a more amplitude. Okay, now see here, and this is the mean position, and let us say this is a point E, and let us say this is mean, again it is a point B. You observe here the height of the wave from the mean position, if it is more, the amplitude is more. Like this sound is having the more louder, so it will give more sound, it will create more sound, that sound is louder now. In the case of here, so now you see here we can observe this small waves, right? The amplitude is less here, the amplitude is less compared to this wave. Here the amplitude is very less. Okay, if sound is producing like this waves, means less waves, the sound is feeble, we can hear very less sound. Okay, if amplitude is more, we can hear louder sound. Okay, now the pitch is depends on frequency. What is pitch? Yeah, now you observe these two frequencies, both are having the same amplitude, but the first sound is producing more waves, the second sound is producing the less number of waves. Now you tell which one is having the more frequency. Yes, which one is having the more frequency? The first one is having the more frequency. Why? Because, and this is having the more waves. What is frequency definition? What is the definition of frequency? Number of oscillations per second is called as frequency. Now in these two waves, which one will create more number of waves? First wave or second wave? First one, right? So it is having the more number of waves compared to second one, right? Here in unit time, it is producing only 3 waves. In unit time, it is producing 1, 2, 3, 4, 5, 6 waves. Total here we can observe here 6 waves. Here we can observe only 3 waves. Now you tell which one has more frequency here? The first one is having the more frequency. This is a high frequency wave compared to the second one. The second one is having the low frequency wave. Okay, let us assume these waves are producing in the same time, 1 second of time. Here we can observe 1 second of time, we can observe here 6 waves are producing. Here we can observe the 2 waves are producing. Now you tell which one is having the more pitch. Which one is having the more pitch? The first one is having the more pitch. Example for the having the high pitch sounder is sound of the baby or sound of the whistle, and these sounds are having very high pitch. Okay, we the sound of the drum and sound of an adult, and these are having the low pitch, means it will produce a less vibrations in the air, and the sound of a baby produce the more waves in the air, right? This means the vibration is more, vibrations is more, the vibrations produced in the 1 second of time is more. Is it clear, everyone? Right, now move on to the next one, audible and inaudible sound. Okay, so audible sound is the sound which we can hear. It has frequency between 20 hertz to 20,000 hertz, between 20 and 20,000 vibrations per second. Okay, then man can hear the sound between this 20 hertz to 20,000 hertz, and this 20 hertz to 20,000 hertz frequency we called as audible sound. Below 20 hertz also we cannot hear, and above 20 hertz also, 20,000 hertz also we cannot hear. The 20 hertz to 20,000 hertz is called as audible range, right? Audible sound is a sound which we can hear, so it has a frequency between 20 hertz to 20,000 hertz. Between 20 and 20,000 vibrations, clear? 20,000 hertz means 20,000 vibrations per second. 20 hertz means 20 vibrations per second. We can hear between this 20 hertz to 20,000 hertz. 20,000 hertz, right? More than this 20,000 hertz also we cannot hear. That is we called as ultrasonic sounds. Ultrasonic sounds also we cannot hear. These are the inaudible sound. That is called as inaudible sound, which we cannot hear, is called as inaudible sound. It has a frequencies less than 20 hertz and the more than 20,000 hertz. Less than 20 vibrations per second and more than 20,000 vibrations per second we cannot hear, right? 20 hertz, less than 20 hertz also we cannot hear, more than 20,000 hertz also we cannot hear. Sound whose frequencies are more than 20,000 hertz is called as ultrasonic sounds. Some animals like dogs can hear ultrasonic sounds. Bats produce ultrasonic sounds. Then who can hear these ultrasonic sounds? Dogs can hear the ultrasonic sounds. Then who can produce these ultrasonic sound? Bats. These bats can produce the ultrasonic sound. Because of these ultrasonic sounds only it will travel in air, right? So now noise and musical sound. What is the difference between the noise and musical sound? So when you stay in the traffic, we can hear the noise of the all the vehicles. Means when you hear the noise, it is unpleasant to our ears. Okay, what is music? It is pleasant to our ears. That means the frequency, the altitude, the frequency, the vibration is same in case of music, but in case of noise, now you see the vibrations of the noise like this. Sometimes you can hear the louder voice, sometimes you can like this. It is a mixing of all amplitudes, right? Like this you will get the vibrations, like this you will get, means it is a noise, right? When the waves are like this, for example, when waves are producing in like this, same amplitude, same frequency, it is moving like this, means it will create the music. Okay, these waves are pleasant to our ears, and these waves create unpleasant to ears. The unpleasant sound to our ears we called as noise. The pleasant sound to our ears we called as music. Now you see, according to this, noise means unpleasant sounds are called noise. It is produced by, it is irregular vibrations. The vibrations are irregular, sometimes higher amplitude, some waves are having the lower amplitude. Mixing of all waves create the noise, right? Sound produced by horns of buses and trucks. This is an example for the noise, right? Musical sound means sound which is pleasing to ears is called as musical sound. It is produced by regular vibrations. Regular vibrations means the height of the wave or the frequency of the wave is anywhere you can see it will get uniform, right? So like that sounds we called as musical sounds, and it is having regular vibrations. And sound produced by musical instruments, like sound of a person singing a song, Okay, when sound of this traffic and sound of this these persons are some singing a song, it will create the music. This is a pleasant to our ears. The sound which is pleasant to our ears is called as a musical sound. The sound which is unpleasant to our ears, which is called as noise. Noise are having the irregular vibrations, but sound is having the regular vibration. Is it clear? Now move on to the next. Noise pollutions. The presence of excessive or unwanted sound in the environment is called as noise pollution. Okay, so right, noise pollution means we don't want to hear like that sounds. That is we call as a noise. That is we call when you hear the noise pollution again and again, what will happen? The causes of noise pollution. Let us see. The noise pollution is caused by the sounds of vehicle explosions, including the bursting of crackers, machines, loudspeakers, etc. In the home, noise pollution is caused by television, radio, and music systems at high volume. Some kitchen appliances, desert coolers, air conditioners will give the more sound. This is the cause of the noise pollution. And harmful effects of the noise pollution. Noise pollution causes several health related problems like lack of sleep, hypertension, high blood pressure, anxiety. A person exposed to loud sound continuously may get temporary or permanent impairment of hearing. Okay, when you hear the high volume sounds, then what will happen after some days? You will get this impairing of the sound. Means impairing of hearing means the permanent loss of hearing. We call it as permanent impairment of hearing. We cannot hear sound. So when you affected by this noise or pollution, then what will happen? You will get like this temporary or permanent impairment of hearing. Means we cannot hear sounds. Measures to limit the noise pollutions. Then how we can measure the noise pollution? Noise pollutions can be reduced by using the silencers in the vehicles. Okay, in the vehicles we will keep one silencer to reduce the sound. To reduce the volume, we are keeping the silencer. Without silencer, when you see the vehicle will create the more sound noise, right? To reduce the sound, we are keeping the silencer in the vehicles, right? And industrial machines and home appliances reducing use of vehicle horns, running TV, radio and music systems at low of volumes. Planting of trees along roads and buildings also help to reduce the noise pollutions. Okay, so along the road, when you plant the many plants, then it will absorb the sound. That means the noise pollution somewhat it will be reduced. Okay, so in this way we can reduce the noise pollution sound from class 8. So if you like this video, please don't forget to share this video to your friends, and please I am requesting you, all of you, please subscribe, share, like and comment. Have a nice day. Please subscribe. Okay, bye.